Hey there, welcome back to the Garuda Podcast. I hope all of you have been enjoying the episode so far, and this episode will now mark the eighth episode of this podcast. I was quite excited to conduct this episode as I got to have a conversation with a CEO of a major space company based out of Colorado. This episode will be focused on the private space industry. The private space industry is in a unique position right now because it is relatively new, yet it has already made a huge number of advancements since it began 15 or 20 years ago. My next guest here is Mr. Daniel Faber, who is currently the CEO and co-founder of the company OrbitFab based in Colorado. This company also operates in the private space industry and is trying to establish an economy which is based in space, for space in space. We also got a chance to have a conversation about the origins of the company, some of its unique and audacious goals, such as refueling satellites in space. We also got a chance to talk about some of the trends which are currently being observed in the private space industry. Now, as you all of you already know, there are so many different players in the private space industry. SpaceX, Blue Origin, even Richard Branson is working very, very hard to establish services in outer space and just outside of our atmosphere. I hope all of you enjoy the next episode of this podcast, as it will provide some key insights into why it is extremely important for humanity to eventually move out of Earth and become a multiplanetary species, and how various players within the private space industry are making an effort to make humanity a multiplanetary species. I hope you enjoy the next episode of this podcast, and I hope you continue to support the Garuda Podcast. Lastly, before we begin, I'll just be playing a short clip from a TechCrunch conference, which basically shows the functionality and engineering behind one of the key innovations OrbitFab has been working on in order to be able to refuel satellites in space. Thank you.
Cars are great for getting around. You can drive them an almost unlimited distance. That's because there's a global network for distributing fuel. If that didn't exist, and you had to tow the fuel around from the day that you bought your car, you'd be towing tanker trailers stretching about 100 yards. It is impossible to imagine throwing away a car when you use up the first tank of fuel. But that's exactly the paradigm that we live with in the space industry. Now, personally, I've had to deal with the consequences of this. A company that I founded in 2011 tried to buy Express AM4, a telecommunications satellite that cost $400 million to build and should have brought in $6 billion of revenue. But because of a glitch in the rocket, it couldn't move to its orbit. It didn't have enough fuel. Because we couldn't get fuel to that satellite, we had to throw it away to avoid it becoming hazardous junk. Now, this is not a unique situation. This happens all the time. These are some of the satellites that in the last decade have had to be thrown away. $100 billion worth of assets, almost 200 satellites. It's time now to start recovering some of that lost revenue. My name is Daniel Faber, and I'm the CEO of OrbitFab. We're building gas stations in space. I spent 20 years in the space industry, built a dozen satellites, several successful products. And I've been frustrated for too long by having a single tank of gas in my satellites. So we're solving this problem in a very simple way. We build these satellite gas tanks. We put them on any available rocket, which gives us the best deal across the industry. When they're in orbit, we manage the logistics and the orbital mechanics. We make the right fuel available to satellites where they need it. They come and get that fuel, and they realize capital expenditure savings over 50%. We take home gross margins over 90%.
Okay, yeah, recording is starting. Yeah, hi, hi. So yeah, thank you so much, Mr. Faber, for coming on the Garuda Podcast. So this is the eighth episode of the Garuda Podcast now. So my guest here is Mr. Faber. So Mr. Faber is the CEO of OrbitFab, and OrbitFab is a company focused on the development of refueling stations in space. So Mr. Faber has a bachelor's degree in mechanical engineering and a double MBA from NUS and UCLA. Mr. Faber has had years of experience working in the space industry, and he first began working as the founder of the UNSW BlueSat project. Uh, Following, one of his more notable positions has been the director and president of the Canadian Space Agency.
Canadian Space
Following,
Society,
he was
not
work.
the agency.
Oh, sorry. Yeah, sorry. Uh, and following, he was also working as the CEO of Deep Space Industries before he started working as the CEO of OrbitFab. So, and lastly, he makes a lot of thoughtful and analytical posts about space and the space economy on LinkedIn, and I'll just be linking his LinkedIn profile in the description below. Yeah, thank you so much for giving me your time, and we can begin. So,
Great to be here.
yeah, thank you. So you've been working like in the space industry for quite some time. What made you consider a career in the private space industry?
Oh gosh, I got to university and didn't know what I wanted to do, and I wanted to make an impact in the world, to do something that was useful for humanity. So I thought for a while about various different things, but addressing existential risks was seemed like the obvious thing. In 100 years or 1,000 years, what is it we will do that will matter? And so sort of went from there to considering how we might get humanity off of Earth. In Australia, there was no space agency, there was no industry, like people weren't presenting a roadmap or a vision that I could attach myself to and help to execute. So I made a list of industries that I thought could support the first permanent jobs in space. That list was tourism and mining and space-based solar power, and started working on those things. So in the end, asteroid mining has sort of been the theme of my career. I've worked a lot of different things around that concept. But yeah, that's how I got into it 25 years ago in Australia.
Okay. Yeah, I mean, every single person who like kind of wants to start a space company always seems to be thinking of it like it's let's say multiplanetary life or getting humanity off of Earth. And when did you contemplate on starting OrbitFab? Like, how did that begin?
So I built a dozen satellites as a mechanical engineer, electrical and dabble in a lot of different engineering disciplines. But then started building companies. So OrbitFab is my fourth company, my fourth sort of serious startup. I did instrumentation for the mining industry, the terrestrial mining industry. High-speed internet for Antarctica. We built the first Ka-band transponders for CubeSats and nanosats. And then I joined Deep Space Industries, where our big, hairy, audacious goal was asteroid mining. But the technology strategy that I implemented there was to build small thrusters that could move satellites around in orbit, that one day we could refuel from an asteroid. So we had a product line of thrusters. And that company was acquired by Bradford Space out of Europe for the thruster technology. So having worked on thrusters that could run off potentially asteroid-derived material, the next step was to build a market in space, because the first thing we're going to sell off asteroids isn't going to be metals for a sale on Earth. The contained mineral value of the metals is several $1,000s per ton of asteroid material, which would be really high if you had that rock on the ground. But the contained mineral value of the water and the hydrocarbons and things we could turn into satellite fuels, that's much higher. It's almost $1 million per ton of asteroid material. So it's a no-brainer that the first thing we should be selling is fuel in orbit, but there's no market yet. So that kicked off the idea And I started talking to companies like, what would you see in the value of having fuel in orbit? What's the marginal value of an extra kilogram of fuel? And over again, we heard from satellite operators that they would see $1 million per kilogram, sometimes more than $1 million per kilogram for every kilogram of fuel we can get them in space. And we know that we can launch it for 2 or 3 orders of magnitude lower cost than that. So we're fairly confident we could fit a business in there. And that's when we decided to drop all the other ideas we were working on and focus on OrbitFab.
Correct. And that just gave me a thought, like, in your opinion, like with regards to um, like starting a space industry, are the problems more related to like the business side rather than the engineering side, or?
There's a lot of really smart engineers in the space industry,
Yeah,
and not a lot of great business models. Like the biggest problem is a lack of exports from space. We have communication services and remote sensing, but that's it right now. We need to come up with more products to sell that can be made in space and sold on the ground, like entertainment content. Tourism is a great export. Maybe space-based solar power. Maybe eventually we get to returning material from asteroids, those types of things. We need more people to be trying out business models. So right now, the biggest challenge is just a lack of people who are willing to take the risks, try a business model, understand the customers, produce something that's valuable for consumers or businesses that they want to use. I'd say that's much more of a challenge than the engineering. That's not to say the engineering isn't hard and isn't important.
Yeah.
But on the ratio of things, I'd say that the business side is less well served.
Okay. Correct. And so, like, just out of curiosity, what was the process like starting OrbitFab in terms of like, getting the engineers or like the permits or, the equipment, the space, etc.?
So the first thing you have to realize when you're thinking about what it will take to start a company, a space company, is that it's a company. And there's no magical pixie dust with space, right? The environment's a little bit different, and it's really hard to go up and press the reset button. So if something goes wrong, it's pretty unforgiving. But it's a business like any other business. So we went through an accelerator that helped us to establish the company. We went through all the normal processes, and as usually happens on the people side, first you hire from your network and people that you know, and then you get to the point where you need to hire outside the network, and you need to bring in some hiring processes and grow the team. And you've got to make sure you don't get ahead of your skis, and keep an eye on cash flow and make sure that there's contracts coming in and investment coming in. So just managing all of that is the normal things you have to do with a business. And if you get all of that right, then you get to implement the projects, which can really make a difference in the space industry.
Okay, great. And I'm not sure if I'm pronouncing this correctly, but the headquarters are in Lafayette, Colorado, right?
Yeah, we're in Boulder County in Colorado.
Okay.
We started the company in Silicon Valley, which is a great place to start. But to grow an aerospace company, the talent pool is the workforce is just much better in Colorado. And so now we've grown the company. I think we were 6 people when we decided that we had to look elsewhere from California, and we're now 60. So it's grown pretty well in Colorado.
Oh, okay. Yeah, that's great to hear. I actually I was going through your YouTube channel. I just got a chance to see the space and stuff.
Great.
Yeah. And would you be comfortable like sharing what your day in the life is? Like, what do you do as a CEO of OrbitFab every day? Yeah.
Yeah, absolutely. And there was a time when I spent my days in the lab, either designing and building and integrating spacecraft. But now that I'm a CEO and the team has grown, I really only have 3 things that I absolutely need to do. One is to make sure that everybody understands which direction we're going. Right, make sure that there's a strategy and everybody knows what they're working on and how it all fits together. The second one is to make sure that we have the right people. Like we can have the right people at the top who know how to who know the market, who know the technology, who understand how to manage the teams and all those kind of things. Those people at the top are absolutely critical. So that's the second job, is to make sure we've got great people at the top. And then the third one is, of course, to make sure we don't run out of cash, right? To make sure that there's
Yeah.
resources available. So I spend a lot of time talking with investors and working with our current investors and other folks, explaining to them, like, just frankly, how big this opportunity is and how much of a no-brainer it is, and making sure they know about our updates and our progress and the fact that we're executing to all of our plans. So those are the only three things that I really have to do. Everything else the team takes care of.
Okay. Okay. And just as a follow-up question, like just because you were talking about investors, so like this is a very niche market, right? So like it's about space and stuff. So how do you kind of like convince investors or people like who are interested about space? Okay, this is something which is really worthwhile.
Don't have to convince people that it's worthwhile. What I have to do is to find out the people who already believe that it's worthwhile, because those are the
Okay.
people I want to work with. That's
Yeah.
actually a really important point. There was a time when I thought everybody would think like me and know that it was important. And then I
Yeah.
came to the realization that no, that's not the case. So then I thought I could convince them all how important it was. And then I realized that's not the case either. What I now do is just find people who already think similar to how I do, and so that makes execution a lot easier. Now, everybody, of course, has multiple goals. It's not just
Yeah.
enough to have a cool vision and a fun project, right? Our employees want to get paid. They want to have great managers and bosses. They want to have great colleagues. They want to work in an interesting place like
Yeah.
here in Colorado. Um, as well as having an impact, right? They want to launch hardware quickly. They want to make sure it's well resourced. Our investors want to make sure that it's going to generate a return, and so
Yeah.
they care about that. But the table stakes are: do you understand what we're doing and why, and do you agree? And that's not something I have to sell people on. That's something I have to
Okay.
filter people on.
Okay. 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 Yeah. Correct. And so like you talked about like everybody has their own set of goals. But when you started Orbit Fab, like what was your goal? And like it's been like I think almost 5 years since you started the company. How far have you gotten with regards to achieving those goals? Yeah.
25 years ago in undergrad, the goal was to create the first permanent jobs in space. Right? We're not going to get off this
Yeah.
rock unless there's an economic incentive, unless there are jobs there,
Yeah.
something that can support people living in space. And so that's continued to be my goal, and that's the vision of OrbitFab, is a bustling in-space economy
Correct.
that can support permanent jobs in space. Our mission to help enable that vision, right? Our mission is to create first the propellant supply chain and ultimately the
Yeah.
industrial chemicals supply chain. So we want to be doing sort of downstream oil and gas, right? Storage and
Yeah.
delivery of fuel in orbit. But then also we want to move into midstream. We want to be the biggest refineries, right? The chemical processing, when you need air, water, 3D printer feedstock, minerals to grow plants, lubricants, industrial chemicals for a manufacturing process, anything like that. That's what OrbitFab is becoming. And so that's what we're building towards. But it starts by winning the downstream side, storage and distribution. And it starts with propellants. That's the niche. And that
Okay.
starts with the gas cap, right? There was no fueling
Yeah.
port for satellites. So right now we're effectively a gas cap company with
Correct.
ambitions.
Yeah.
And so how far
Yeah.
have we got? We've sold a bunch of fueling ports. We've flown. We've got flight heritage on the fueling ports, so that's a viable product. We've already signed some agreements and contracts with the U.S. government and with commercial companies to provide fuel on orbit. So we're building those systems now to execute on those deliveries. So we're well on the way to creating and dominating that downstream market. And then in 5 years or so, I want to be pushing towards
Yeah.
the midstream and looking at chemical processing.
Correct, correct. And like just as you said right now, like there's a lot of things that that we would need in space. So you know, like when the private space industry started, I think maybe I was like 5 or 6 years old at that time. Like there was not like this sort of secondary economy, right? Like there was just Most people just used to like think about like private rocket launches or satellite launches, and now we're kind of like, I would say, witnessing an era where this like giant second economy is taking birth, where we need like these individual components or raw materials, or even like software development. And
Yep.
OrbitFab also kind of seems to be tackling that specific problem. Like what sort of trends have you observed about the private space industry, like since it began and like right now in 2023?
It's interesting. The space industry can be defined in a few different ways. Um, the bigger space industry that includes the downstream. So a telecommunications satellite enables a company that's selling internet, right? And so do you
Yeah,
include $100 billion of internet into $5 or $10 billion of direct satellite revenue, or do you just include building the satellite, which is only a few $100 million, right, and launching it? And so
yeah,
there's downstream, how we use the capabilities, from GPS to telecommunications to all of the remote sensing and radar and like all of the phenomenal tools that we have. So the downstream is using that, and then the upstream is building and operating. That's one way to look at it, is downstream, upstream. Another way to look at it is in space for space versus the on the ground, right? And
yeah,
so
yeah,
while the downstream markets have been expanding really rapidly, and they're much bigger than the upstream market, right? The upstream market's 10% the size of the downstream market. That's the hardware that actually gets launched into space and the rockets. So if the downstream market right now is $500-600 billion, 50 or 60 billion is building and launching the satellites and operating and that kind of stuff. Much smaller part is products and services created in space to be sold and used in space.
yeah,
And this is very, very small. This is the nascent industry of tow trucks in orbit, right? Of
yeah,
gas stations in orbit. We're creating value by creating services that are used in space. That is completely new. And the growth rate of that is very, very high. Now,
yeah,
if you look at what can be done in space with manufacturing and not just the vantage point, but what you can do with zero gravity, like the fact that you don't have
yeah,
buoyancy, you don't need to store things like with walls. You can do processes and create materials that you can't create on Earth. That is going to revolutionize all manufacturing. And if a step in your process needs zero gravity, you put the whole process in space, otherwise it doesn't work. And so
right,
eventually, so much of manufacturing is going to be moved off Earth,
yeah,
and power generation associated with it and everything else. In 50 to 100 years, the economy in space is going to be bigger than the economy on Earth, right? What we're building
right,
is not the Earth economy, right? It
yeah,
will
yeah,
help the Earth economy. A lot of the goods and services will be sold into the Earth economy, but what we're creating is the space economy. In
right.
space for space. That is going through incredible growth right now, but it's very small.
Mhm. Yeah, correct, correct. Yeah, that's an interesting way of putting it. Like I didn't even think about it that way. Yeah,
It has to
and
be.
yeah,
Like, if you want to create permanent jobs in space, what goods and
yeah,
services are they creating, right?
yeah,
And if
yeah,
there's an export job where
yeah,
you're creating, say you're helping run and maintain the factory, which then produces things that are exported to Earth, or you're helping with the tourism, right? Roll out the red carpet, cook the food, what have you, or with entertainment content. Maybe you're filming the movie or running the lights and what have you for shooting a movie in space. Those are export jobs, right? The dollars come from selling things to the
yeah,
population on Earth. Once you have an export job, it supports 10 to 100 internal economy jobs, because that
yeah,
person needs food and needs a place to live and needs their air to be clean and
yeah,
everything else. And
yeah,
they want to have a day off and not go stir crazy. So they're going to want to have some kind of entertainment. And all of the people supplying those also want to have those things, right? And so for every export job we have in space, we're going to have 10 to 100 internal economy jobs. And at the moment, there are 0 export jobs in space. Right? How do we create
okay,
permanent jobs in space? That's been my obsession for 25 years.
okay, okay, okay. Yeah, and so like you've been like let's say an entrepreneur in this space for like quite some time. what do you think is like the biggest misconception people have about like private space companies in general?
Biggest misconception. The biggest misconception is that there's magical pixie dust. Right?
Okay.
There is none. It's not like you hand it to NASA and they sprinkle it with pixie dust and now it's spaceable. No, you can put anything into space. Bricks work just like bricks in space. Refrigerators will work like refrigerators. Everything will work. There's quirks, right? You have to think about how it's being done and do it a bit differently. And we don't have a lot of experience working with those differences, which is what makes it seem hard. Right? And there's no reset button. At the moment, there's no satellite servicing. There are companies just starting to build tow trucks. But without a reset button, it can be very unforgiving. And if something goes wrong with a rocket, if you're lucky, you get to pick up the pieces of aluminum shrapnel. Right? It's
Yeah.
not like you can just walk over and thump the side and it'll start going again. No. You pick up the shrapnel and try and figure out what went wrong. So it can be unforgiving. But the environment is actually pretty benign. Once you have something that works, it's a very, very clean environment in space. There's nobody poking fingers at it. There's no one tripping over wires. There's no one driving backhoes through your communications cables, right? Planes don't fly over the top of you. Like everything is below you, and so it's very reliable when you get it to work. But getting it to work takes thought because you're in an environment that not many people have thought about. But there's no pixie dust. It's a lot easier than what people think.
Okay. Okay. And like since when I started researching about you and OrbitFab in general, one question I just kind of had was like, how did you come up with the name OrbitFab? Like, how was the process like? Yeah.
It's an interesting one. So I spent a year between Deep Space Industries and starting OrbitFab. I spent a year looking at different business models. And so OrbitFab was clearly what we settled on. But we started a company around one idea of manufacturing semiconductors in space. Because there's no buoyancy, you can make a semiconductor made of materials that have very different densities. But in zero gravity, there's no buoyancy forces. It's not stressing the crystal. You can make a crystal with 3 orders of magnitude lower defect densities, which is a huge advantage. And so that was the idea, and thus the fab is because we're looking to be a semiconductor fab, or at least a semiconductor material manufacturing. We ended up walking away for that for various reasons, and pivoted into the fuel supply. But we kept the name OrbitFab after the pivot. So that's actually why it is. It's not because it happens to be the start of my surname Faber. That's just a bonus.
Okay. Yeah. Great. And so like so basically like OrbitFab right now is trying to like solve the problem of like satellites running out of fuel. So what made you like consider solving this problem specifically to begin with? Like,
So not actually so much about satellites running out of fuel. That implies that you put your satellite up for 5, 10, 15 years. You've got to the end. And 85% of satellites get to the end and they're still operating, still have customers, but they run out of fuel. But that's not actually the main thing that we do. The main thing that we're doing is changing the way people can operate in space. When you have a satellite in orbit and you're trying not to use any of the fuel because it's a consumable, right? If you use it up, you reduce the life of the satellite. But you really want to follow where the market is shifting to. You really want to run a satellite servicing business where you can upgrade the satellites, you can deorbit the satellites, you can move the satellites around. You can't do that without fuel. If you look at the US Space Force, because they want to move around, right? They want to be over a certain place at a certain time. They want to keep everybody else on edge a little by being able to move around. But every time they move a satellite, they have to call a 3-star general, because it reduces the life of the satellite. And those are very expensive assets. Just one example of how important it is to be able to move, and yet they can't at all. So the value that's created from that is enormous. But the reason we started is we talked to a lot of people about that, and they were saying it's more than $1 million per kilogram of marginal revenue or value. And there was a paper published for Space Force saying it was, averages sort of $800,000 a kilo. And that's average, right? So they have applications worth more than that. It's enormous value that's created. And if you, anyone listening to this is considering starting a business, that is a reason to start a business. Not because the technology is cool, not because you have a great vision, right? Those are good reasons to be interested. Those are good reasons to look around for the opportunities. But start the business only when the customers have such an incredible need, when the problem you're solving creates so much value for the customers that they're prepared to pay for it. That's when you want to start a business. So that's what got us going on OrbitFab. It was the 8th or 9th conversation when we heard $1 million per kilogram. That's it. Shut down everything else. This is an opportunity that is worth solving.
Okay, correct. And have you already helped like certain like at OrbitFab has OrbitFab already helped like certain customers or partner companies to solve this problem already, or is it still ongoing? Or
And we've signed contracts. We're working on those first deliveries. We haven't made that first delivery yet. Scheduled for 2025. So yeah, keep an eye on the press coverage of that and on the company websites and social media. We'll be talking a lot more about how that goes. We have solved other problems along the way because we're launching our test spacecraft. We tested the fuel depots. We tested the fueling ports. We've helped other companies to fly hardware that they wanted to test in orbit that would allow them to build better tow trucks, which is great. We want them to build tow trucks because they'll need fuel, right? But so we're able to offer them things. So we've done a number of things that have helped a lot of other companies. But in terms of supplying fuel, the date is 2025. That's when it's game on.
okay, great. And so one question I had was like I was just curious about this is like how difficult is it to like store gas or propellant like in the gas station in space? Like how challenging is that? Right?
It's a really good question. It depends on the fuel.
Okay.
So when you look at rockets that go up, they often burning liquid hydrogen or liquid oxygen. Those need to be kept very, very cold, and they slowly
Yes.
boil off. It's very hard to store them long term in space. You definitely not for something as small as a satellite. And so the satellites have to use storable propellants. So things like hydrazine or hydrogen peroxide, and those chemicals contain a lot of energy. So they often burn with themselves, so you don't need to have a fuel and an oxidizer. You just have this chemical and you put it over a catalyst, and it decomposes and burns with itself. So those are some of the interesting fuels. There's other types of fuels that don't contain the chemical energy that you put energy into electrically. So you can have a big solar panel, and then you could put the energy in from the batteries. And that's something like xenon or krypton, which is a noble gas. And effectively, you put it through a particle accelerator. You put it through an ion engine. And that's very much more fuel efficient. It takes a huge amount of power. So that's a compromise. We are able to supply both of those because regardless of whether it's propellant for an electric thruster or propellant for a chemical thruster, it's still your consumable. You're still going to run out if you try and do anything interesting in space. And so, yeah, we provide both types of propellants.
Okay. And I think in like the TechCrunch conference and like in other podcasts as well, you like avidly talked about the problem of surface tension in space because like there's no there's no gravity. I mean, there's no I believe like it's a zero gravity environment. So like obviously you said this before, like with water, it is like a lot harder to transfer water because of surface tension. But how does it affect a propellant or like some sort of like other thing to power a rocket or a satellite?
Interesting. It's really hard to get a feel for how important gravity is because we've always had it. We don't know what happens. Like we've got no intuition for what happens when you take gravity away. For example, take a pump. Most pumps rely on the fact that water will flow downhill. And if you put too much air into a pump, it can just lock out and stop being able to pump, right? In zero gravity, because nothing flows, it's not like you can self-prime a pump. How do you prime a pump? Like it'll just keep churning on the air and nothing will ever move. You can't flow water downhill or fluid downhill into it. These kind of things are not intuitive. And because they're not intuitive, it's difficult for engineers to design to that. We don't have a lot of experience. I can't say, oh, last Tuesday I saw that, or oh, I'll go down to the lab and just try something. It doesn't work. We have to think through it. We have to model it. That makes it a little tricky, and so we've got to be very mindful of that type of thing. So yeah, the great example with surface tension on the space station, when we were launching our prototypes for the space station, we had 3 gallons of water. Very simple. We just pumped it from one tank to another and back again a few times to check that our pumps weren't going to get airlock and that everything was going to work well. But when we went to put that up on the space station, we had astronauts pressing the buttons and keeping an eye on it. NASA was very concerned that if there was any leaks in our hoses or our tanks, that if you leak a gallon of water on the space station, it gets onto an astronaut's face, they can't brush it off because there's no gravity to drain it. And the strongest force is surface tension. So if you try to brush it away, it just rolls straight back again.
Yeah, right.
And so it can be very dangerous. You can drown an astronaut in a gallon of water, which is amazing.
Right.
Like, you can't brush it away. You can't call for help because you're under an inch of water. What do you do, right? It's quite dangerous. And so those kind of things aren't really intuitive. The same thing is happening inside our tanks. Where is the fuel? It's stuck to the upper right, or it's floating through the middle of the tank as a blob. I need to get the fuel out the exit. I need to get it into a pump, and it's not wanting to behave at all. So we've got to come up with really creative ways to make sure that the fuel is always where we want it to be, and to move it around and to get it into the customer's tank and be able to deliver it, and then measure it. How do you measure flow when there might be air entrained in the fluid, but it's not separating? It's just really gnarly questions when you get down to it, that one day will be so intuitive because people will have just had more experience living and working in space, that have had more experience building machines to operate in space. They're going to come up with things that everybody after they're invented is going to say, well, that's obvious. How else would you do it? Of course, that's how you handle fluids in space. Right now, we just don't know. We've got a huge amount to learn.
Okay. Yeah. And so just another follow-up question. So you about the water project where you were able to I think OrbitFab was like the first private company to resupply water to the space station. So I believe you had said this before, like NASA had said it would take like 24 months, I think, to get this done, but OrbitFab was able to like do it in just 4 months, I believe. What kind of steps or advancements did you take to like accelerate this project?
Yeah, that was a really interesting project. I mean, NASA was rightfully worried because it's a safety hazard. Right? Water is a safety hazard on the space station, and more so because we pumped the water into the space station water bus after we'd finished, and that water supply, there's pipes all over the station and everything to keep the water flowing. They're worried if we overpressurize it, because we have a pump that can force the water in. If we overpressurize it, will it spring a leak? In which case they've got water now all through the space station. They might have to evacuate the $100 billion space station. Right? That would be a really bad day. So they categorized this as a catastrophic level hazard, and they threw the book at us, right? And you can completely understand why. What we had to do was to understand those requirements, and their normal process takes 2 years. And they told us that, right? This is what we expect. Go away and think about it. Come back in a few months, and we'll work through the problem. We were a startup company. We didn't have 2 years. We had to execute. So what we did was to talk to all the stakeholders, and there were quite a few of them, and say, right, what are you worried about? What are you most worried about? Okay, I see this stack of requirements, but some of those are for biology experiments, and some of them are outside the space. Most of them don't matter. What really matters? Okay, who does it matter to? And inside NASA, it's not a faceless bureaucracy. There are individual people who really intimately understand the hardware that's on the space station, and some of the things that have gone wrong and some of the things that could go wrong. And you talk to them and you find out, okay, I'm worried about this type of leak in this type of situation. So you can ask them, okay, what does it mean to control that situation so that doesn't happen? And they say, well, I want it to be in a sealed container. But then you've got to have a pipe coming out. Okay, well, I want that to be redundant. I want that to be controlled. And that could be controlled by having this method or this other method or this other method. And you talk through them and say, okay, well, I can do that particular method really quickly and really cheaply. So I'm going to do that method that you've just suggested and not the others. And sometimes they'll say, well, that's not what we've written in the documents, but it would solve the problem. We'd come up with creative ideas. There's, okay, if you implement it that way, I'll sign a waiver to say the way that you've implemented it is going to be safe. And therefore, this meets the intent of the rule, even if it doesn't meet the letter of the rule. And we had to do that over and over again. So a great example, when we went to test the electromagnetic interference, this correct, it's got electronics, and all electronics emit radio waves, right? And you have to go through a lot of tests. Like if you pick up a piece of hardware on the ground, you've got CE, UL, like all these certifications on it. That means somebody's tested it to make sure it's not going to interfere with everything else in the world. And the only reason that all our electronics works is because we have this testing. In space, there's a bunch of sensitive equipment, and it all interacts a little differently. And so there's a test you have to do to make sure there's not emitting anything that's going to interfere. And they have a chart that shows you have to stay below this line, and it's by frequency. And they say, okay, something's sensitive here and something sensitive here, and you've got to make sure nothing's emitting in those areas. And so rather than do the test ourselves and then try to fit below that curve, we took our equipment to NASA Marshall Space Flight Center, and they tested it for us. And these are the people that also sign off on the results. And when the results came back, right, we got the wiggly line, but it was above some of the notches. It didn't pass the test. But they looked at it and they said, okay, this notch is here because there used to be an experiment that was sensitive in that area, but we haven't used that for 5 years. And this one over here, that hasn't been on the space station for the past 2 years. And so this one doesn't matter, and this one doesn't matter, and they sign off that you met the intent of not interfering, even though we didn't meet the letter of the chart. And we wouldn't have got that if we'd have done the test ourselves. We only got that because we asked them to help us with the tests. We took our equipment, we talked to them and sat with them, and they said, this is what you have to meet. So we did that over and over and over again and got through everything in 4 months. So it can be done.
Okay. Yeah. And so for like any sort of project or endeavor, what sort of like philosophy or approach do you use like to get it done?
What philosophy or approach? There is so much to unpack in that question. This comes to the art of engineering, is deciding what's important and what you spend your time on. And a lot of it's experience, but also a lot of it is attitude. We are not trying to be risk avoidant. You can't avoid all risks. If you want to avoid risks, stay at home under your bed. Right? It's a dangerous world out there. What you want to do is to manage the risks such that it's reasonable. Right? The consequences are suitably matched to the opportunities. And so that you have to be relentless in trying to find ways to reduce risk cheaply. And it works the other way around. Ways to increase the scope, right? Increase what you can achieve cheaply. But if you de-scope something and save a lot of money, that's great. If you can de-scope something and save a lot of risk, that's great. You're constantly trading these things off. And so you have to have a mind that can see where the opportunities are and constantly weigh off the risk reward of all of those opportunities. And it's a multi-dimensional thing. Our brains are really good at it, but it depends on the attitude of the person who's wielding that weapon, right? Your brain is great, but you've got to approach this with the right mindset. We see a lot of people in the government who aren't incentivized to succeed. There's no reward for success, but there are penalties for failure, right? It can be career limiting to fail. So if you don't advance because of success, you don't get rewarded from success, but you get penalized for fail, the best thing to do is to do nothing, because you can't fail if you do nothing, right? It's stay under the bed. And that's what happens in bureaucracies. And it's not that these people are stupid. It's not they don't want to do interesting things. It's that they're constantly incentivized to go slow, do less, do nothing, avoid risk, because that's how they get promoted. It's terrible, right? It's very different from the commercial industry, where if you do nothing, your company goes bankrupt and you don't have a job. Right? A clear incentive, but also if you take too much risk, your company will go under, like something bad will happen and you won't have a job. So we're forced in a commercial company to manage risk. But still, we find people are on a spectrum. And sometimes you want more risk when you're prototyping. Sometimes you want less risk when you're producing a high reliability part. So we've got to have our culture shift to the stage that we're at with the company. It's really important. When we're hiring, we pay a lot of attention to that. It's non-trivial. So yeah, we look for people who are culturally attuned to the thing that we'll be working on, to the thing that we need them to achieve.
Okay. Okay. And I just had like one last question about OrbitFab. So I wanted to talk about like the gas cap. I think it's called RAFTI, right? Yeah,
That's right. Yeah.
sure. Um, so so this like particular gas cap, it would have to be I'm not sure, but it would have to be inbuilt in like new satellites, right? Or could it also be installed on like existing satellites, or it would have to be new satellites, right?
Have to be installed in new satellites. And so that means all the legacy satellites that are in orbit, they can't directly be refueled by our system. However,
Yeah.
we can refuel all of the new tow trucks that are going up, all the satellite servicing vehicles. And some of those can attach to the legacy satellites and provide a jetpack to keep them
Yeah.
alive. Some of them have complex robotics to be able to add fuel to the
Yeah.
old gas tanks. So there's a lot of things that those tow trucks can do to serve the legacy satellites. And we make sure those tow trucks have enough fuel to be able to do that in a cost-effective and efficient way. And so indirectly, we serve the legacy satellites. And then going forward, we're able to directly refuel all of the satellites. And there'll always be a job for tow trucks. Right? Our refueling system can only refuel a prepared, collaborative, like cooperative system that's got no dings and dents in it, that's behaving properly. As soon as it's got a problem, call AAA, call a tow truck. Right? You want to do assembly and new construction or something in space, go get your robots, go get your tow trucks. That's going to be important. What we do is just the fuel, and we supply the tow trucks, we supply the operational constellations.
Sure. Sure. And so like let's say like a satellite is about to like run out of fuel. Like how would they approach OrbitFab to like say, okay, we need some fuel or something?
Well, they didn't have a fueling port and came to us. We would direct them to some of the satellite servicing companies that we thought could provide that service, attach and keep them going, and that kind of thing. And we would work with the servicing company to make sure they were fueled. If, however, they've taken the fueling port already, hopefully we're in discussions with them before, so years in advance we know that they're going to be needing fuel, and we can have it pre-positioned where they want it. If they've installed a fueling port and they haven't arranged for that fuel, then we've got to find out how long until they run out, and we might have to move very quickly. And that can be expensive because it can take a lot of fuel to move quickly, right? And they're going to have to pay for the fuel to move the fuel shuttle, like the delivery vehicle, if they can't come to us. So yeah, we would work out where they are, how to get there most effectively, or whether they should come to us, like how the orbital mechanics would work. We have a big model, a lot of MATLAB simulations and everything else. And so yeah, we can pump out results very quickly on what is the most efficient and effective way to get fuel to you, and we'll know how much it's going to cost and everything else. And then if we sign a deal, we bring the two vehicles together, we'll transfer the fuel, and we'll get out of there, and they can keep making money, keep doing their business.
Okay. And so just my final question just for you is so you've kind of been known as like an industry veteran because you've been operating quite some time in this like particular business or industry. So like somebody who's like, let's say, just graduating out of college or wants to start their own space company, what sort of advice would you want to give?
I think you're actually the first person to call me an industry veteran, so you've made me feel old. Thanks. Let's see. Different people take different paths. The path that I took was just to get in and start doing it. Right. I in first year undergrad, I realized that nobody in Australia could teach me how to build satellites, let alone anybody at my university. And so the internet had been invented. I managed to connect with people that were building satellites in their spare time, amateur radio satellites. This is before CubeSats. And they sent us the plans to the satellite. And so we started building a satellite based on their plans and our own modifications and all those kind of things. And I spent 4 years at university learning how not to build a satellite. but I came out of that with enough knowledge about satellites and enough contacts. And I'd helped organize space conferences in Australia. Not that they're very big affairs, but I got in and got involved, and I managed to get a job in Canada building actual real satellites. And that sort of, my career went from there. But even while I was building satellites, I was helping a guy who wanted to launch satellites out of a gun, to launch rockets out of a gun, doing that in my spare time. I was working on electric nuclear fusion reactors and sensors for detecting minerals on the moon. I did a whole bunch of things in my spare time. Restless is how I was. But yeah, jump in and get things done is always been my approach to things. But then I see other people who are very successful who've gone off and got experience from other industries. And there's a lot of hubris in the space industry. We need to bring in more expertise from outside the space industry, where people have got, there's much more of the economy outside it. And so we need to bring that into the space industry. So go and my advice would be, do what you enjoy, do what you're passionate about, become the best at what you do. And if you're interested in space, you'll find that you can apply that to space and that there'll be opportunities.
Those are all the questions I had. Thank you so much for giving me like almost an hour. I'm sure you have a very busy schedule, but thank you so much for giving me your time. Yeah.
John, you're welcome. I hope this has been useful to your viewers, and I hope to see them around the space industry.